Hi everyone, welcome to another episode of Pen and Paper Programming. We are continuing to look at problems in Elements of Programming Interviews book. Today we're going to look at problem 4.7, which is asking us to compute x to the y, write a program that takes a double x and an integer y and returns x to the y. Book also talks about this, but the brute force approach would be to multiply x by itself y minus 1 times to get the result is one approach. This approach has linear runtime complexity, and as the book shows that we can do better than that. And book calls out few important points, one of which is the properties of exponentiation in mathematics, right? So for example, if you have x to the n plus m, that's the same thing as x to the n times x to the m, right? This is a property that's worth calling out because the solution takes advantage of this. So in concrete terms, if you have 2 to the 10, 8 plus 2, the same as x to the, which is 2 to the 8 times 2 to the 2. The example the book gives here is that if you have 1.1 as an input to the 21st power, instead of actually, like this is the same thing as you can just multiply 1.1 by itself, and then that would be the same thing as 1.1 to the 10th power, right? So this would give us 1.21, 1.21, which is to the 10th power. By multiplying this number by itself first, we were able to reduce y by half, right? So this is basically the property that the solution has taken advantage of. And before we take a look at the solution, I'm wondering if I need to call out anything else. But I guess, as we walk through the solution, this is going to become more obvious, right? So the solution is basically trying to reduce number of multiplications we need to do, and the fact that by multiplying x, in this case our input x here, by multiply, or 1.1 here, right, by multiplying it by itself iteratively, let's say that this is 1.1 times 1.1, which is 1.1 to the second power, but what if you were to do it to the third power or the fourth power? You need to you would reduce basically a number of multiplications you would need to do. So solution is iteratively increasing the power, the x multiplying by x by itself, then it's multiplying x to the second by itself again, x to the fourth, then multiplying again to the 8th, to the 16, exponentially basically increasing this number to reduce number of times that number needs to be multiplied by itself, right? By increasing that exponent, we are reducing y, which is number of times that we need to multiply x by itself. Instead of doing x times x times x times x, we're saying that we're going to multiply x times x to the second power, next time x to the fourth power, next time x to the 8th power, to the 16, to the 32. That way, basically, that y number keeps getting less and less and less, and that way we are able to achieve not linear runtime, but we are log n runtime, which is much better. So let's take a look at the solution real quick. I captured the solution that's given in the book, and perhaps what we can do is quickly give an example and walk through the code together, right? So let's take a look at it. Let's make sure that you can see my screen. So what are our inputs we're going to give? Okay, I almost hit my dog. Okay, let's take a look at an example. So we have a power function which takes x, which is double, and then y, which is an integer. And we're going to walk through this code, but let's actually capture a few variables here. We have, what do we have here? We have result, we are taking x as an input, we are taking y as an input, and we have power, right? These are our variables. Anything else? Okay, let's start with this, right? So at the very beginning, we have result initialized to 1.0, and then we have power, which is y. Let's take an example as, let's take our x is 2.2, let's say, and our y is 5, okay? And that would be 2.2 to the 5th power. I'm going to write this in binary. As you will see, y is 2 times 2 to the 0, wait, that would be 1, 2, 4. Okay, so this is the binary representation, right? 1, 2, 4, 8, that would be 5 to the 2 to the 5th power. So let's walk through it. So we're starting with, I'm going to move this up a little bit more here. Hopefully you can still see it, right? So our result starts with 1.0, and our x is initialized to 2.2, and power, which is y, is 5. And that is 5. Okay, if y is less than 0, which is the negative case, power becomes -1. In this case, we don't have a negative case, but let's, well, in this case, what happens is power becomes minus power. That makes sense. And then x becomes 1 over x. So that makes sense, right? You just basically 1 over 2.2. As you are multiplying, it's going to get less and less. Okay, cool. But in this case, we're looking at a positive number, so we don't have to worry about negative case right now. So while power, we're going to iterate through. If power and 1, in this case power is 5, I'm going to keep track of binary number here, 0, 1, 0, 1, right? When we do power and 1, we've seen other videos, what we are really doing is that we're extracting the least significant bit here, which is this number here, and that's going to become, this number here is going to give us a 1. So when we do that, we are getting true, which is 1. If power n 1, which is true, result is going to get result times x, right? Our x is 2.2, so result times x would be 1 times x would be, now our result is 2.2, right? And what happens next? Now we are going to, again, in the, like as I mentioned at the very beginning, now we're going to multiply x by itself. Now, don't forget, right? Initially, it starts with x as 1, which is x itself, I'm sorry, it's 2.2. And the next time, it's going to be multiplying by itself, x to the 2nd power, which is, I don't know what, 2.2 times 2.2, which is 4.84, right? So we are initializing x to this number here. That would be 4.84. And power becomes, we are right shifting power. Power is going to be, by right shift, it's only going to be these two. Then our power is, I'm going to actually write this in initially 0, 1, 0, 1. This is the decimal and binary, and that's, we're going to right shift it 1. That's going to become 0, 1, 0, right? 1, 2. In this case, power is going to become 2. Hopefully that was clear. Basically, we are right shifting by 1. We got rid of this 1 right here. It became 2. So we go back to our while loop again. In this case, we are saying if power and 1, basically what we're saying that is the least significant bit is a 1, right? But if you're looking at this power right now, which is number 2, no, least significant is not a 1, it's a 0. Therefore, we are going to not multiply result by result times x. We're going to come back here and we're going to say, well, x is x times x. X times x is, as I said, in this is x to the 4th. Initially this was x to the 1st, now x to the 2nd, x to the 4th, right? And so that's going to become 23.42. And then what's our power? We're going to right shift our power by 1. That's going to become 0. In this case, 0, 1. And that's becoming 1. Now we go back to our loop. I'm sorry. That's right. Our result hasn't changed because of that, and we'll come back to our loop again. If power and 1, if the least significant bit is 1, in this case that is 1, we are going to multiply result by x. What's our x? 23.42. And what's our result? 2.2. 23.42 multiplied by 2.2 is 51.53. Okay, so our result is now 51.53, and we're going to come back here. X is x times x. So basically this number here, 23.42 times 23.42, I actually don't know what that number is, but I don't think we're going to need to use it anyway, because we're going to, as you will see, we're going to come back, we're going to run out of the loop, but this is some number, let's say 400, some other weird number, right? And then power becomes right shift by 1. In this case, when we do that, power becomes 0, right? 0, 0, 0. Now, the reason I don't need to calculate this is because we're going to run out of the loop, but when we come back, this is no longer true, and our result is 51.53, and we're going to return that number. So we only had to do, I believe, 1, 2, 3 multiplications here, and our y was 5, not 5 multiplications. So as you saw, what we are really doing here is the fact that instead of multiplying 2.2 5 times, we multiplied it once, and the second time around we multiplied it with x to the second power, and the third time we multiply by x to the fourth power, right? Each time when we multiply, we are multiplying with a larger x, so that our iteration, which is y, would have to be going down and further. Our power basically keep reducing, because of the fact that we are multiplying x by a larger number, and we don't need to multiply it as many times as we did in the brute force solution. Okay, so I'm going to wrap it up. So again, we are taking advantage of the fact that by reducing the number of multiplications by actually increasing x iteratively and reducing y. Hopefully that makes sense. If you have any questions, put them in the comment section. And if you find this video useful, hit the like button. It's really helpful. It motivates me to do more videos. And please subscribe to the channel. Thanks for watching and listening.